Hello and welcome to Unit 3 Practice Problems Part 2. In our previous part, we went over these top 3 questions right here. But today we're going to be going over using L'Hopital's to evaluate a limit and then using related rates. So in the first question, it says use L'Hopital's to evaluate, and then it gives us this limit. So the first thing that we should do is check to see if L'Hopital's can be used, and that's if it says 0 over 0. Or infinity over infinity. So in this question, it says the limit to 2, and the first thing that we should do is plug in the 2 in the equation or the expression. So we've proven that L'Hopital's can be used. And now the next step is to find the derivative of the top part and the bottom part, so the numerator and the denominator. And then use that to see if we can plug in our x equals 2 or x approaching 2 and see if we get something that's not 0 over 0 or undefined. So I'm just using chain rule. So we're not trying to find the derivative of the entire thing, but instead we're trying to find the derivative of only the numerator and the denominator as separate parts. And now we can plug in the approaching 2. So we get 5, and that's 12 minus 28 plus 10. 12 minus 18, negative 6. No. So our answer is negative 6 over 5. And now for the next one. It says air is being pumped into a spherical balloon at a rate of 5 centimeters cubed per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters. So if air is being pumped into the balloon, then the radius is increasing, because if this is the balloon and then air is going in, it'll just expand and get bigger. Let me draw a better picture. So it's really good to draw a picture for these, and in our case, we need to find how the volume is increasing and what rate it's increasing. And so finding what rate the volume increases will help us find the radius and how that increases as well. So we have volume equals 4 over 3 pi r cubed. So it says in the problem that air is being pumped in at a rate of 5 centimeters cubed per minute. So if it says the rate, then we know that that's talking about the derivative. And so the derivative of v equals 5 centimeters cubed per minute. And so the derivative of r is what we're trying to find. So it says determine the rate at which the radius. And so this is just, we don't know what it is yet. And so it also says that increasing when the diameter of the balloon is 20 centimeters. So we're given that the diameter is 20, and that means that the radius is 10. So we're trying to find when the radius is 10, what the rate of change is. So we're trying to find the derivative of this equation right here. So we get the derivative of v equals 4 over 3 times pi. So these are our constants. And then 3r squared times the derivative of r. And then we can simply simplify that out. Bam. And now we're trying to solve for this right here. And we know what this is. We know what this is, and these two are constant. So all we really need to do is plug it in. So from here we have our 5. 5 equals 4 pi times 10 squared times the derivative of r. And then we can solve out all the way. 5 equals 400 pi times the derivative, and then 5 over 400 pi. So if you have a calculator, if you just know how to do it, so like 4580, 1 over 80 pi equals the rate. So we can organize it out. We know step 1 is to draw a picture, know what we're trying to solve for. Step 2 is to figure out what we have and what we don't have. Step 3 is setting up our derivative equation. And then step 4 is solving. And obviously step 5 is writing it with the units, centimeters over minute. And that's it for this video. Thank you for watching.